Okay, the aim of this tutorial is to evaluate this integration. And before we get into it, we need to, what I'd like us to do is to go over some of the main concept of integrating trig functions, and also talking about the trig identities which are needed in order to carry out some of the integrations. Alright, the first one is that we have learned from previous tutorial is that the derivative of the sine and cos function. So if you have y equal sine x, then y dash with the derivative of y is going to be cos x. Okay, and if you have y equal cos x, then y dash is equal negative sine x. Okay, so this is important because if we were to do the inverse, basically integrate cos x, you will get sine x. All right, if you were to integrate negative sine x, you will get cos x. All right, so this is important to understand. So therefore, if I have a integral of cos x dx, the answer is going to be sine x plus a constant, because this is an integration which is not defined by the limit or the borders at the integral there. So that's why we add the constant. Now, if we want to check your integration is accurate or correct, then you just have to differentiate this answer here. So the derivative of sine x is cos x, so give us this one here, and the derivative of the constant is going to be 0. So that is the first example. Second is if you have integral of sine x dx, then here, because there is a minus there, and we haven't got it here, so the answer must be negative cos x plus c. And again, if you want to check your answer, you could just differentiate this one here. So therefore, the derivative of cos x is minus sine x. Minus followed by minus will give us a positive. Right? So we are correct. And the derivative of a constant is going to be 0. So these are the first principle of integration and differentiation. What about if you have something like double angle? So for example, if we have this integration, and I say cos kx dx, what should be the answer? Well, we know it has to be the sine kx plus c, but if you were to differentiate this to go back to this one here to check for accuracy, you'll get k sine kx, right? If I was to differentiate this one here. Okay, let's write it down here. The derivative of sine kx is going to be, first you differentiate the inside of the trig function, sine. That will give us k. So the derivative of kx is k, and then multiply by cos kx. You differentiate the sine, which is cos. But the problem is I don't have k here. So how do I correct that? Well, it's by dividing by k. Okay, so we say is 1 over k. So that's very important to understand. Well, so same thing if you have sine. Let's do that. Sine, again, I'm going to keep it positive. Kx dx, it's going to be negative, of course. 1 over k cos kx plus c. Again, let's check by differentiating. So differentiating cos x will give us, cos kx, sorry, will give us negative. Let's write it down here. Cos kx, if we differentiate it, we'll take the derivative of cos kx. That will give us negative k sine kx. Again, the problem is I don't have a minus and I don't have a k, so I need to divide by minus k, which is the equivalent of minus 1 over k. Same thing. All right, so that's something you need to, well, understand and know how to work with. Okay, so let's move on to the power ones. Okay, so the one I'm talking about is, let's say we have this integration to evaluate, or to calculate rather, because we're keeping the borders open, we're keeping it not defined, sine squared x dx. How do you integrate this one? Well, when it comes to power of 2 or power, any power, you need to use the identities you have learned. The first one is a famous one, cos squared plus sine squared x is identical to 1. Now there's another one here which is also going to come handy if you have sine 2x. So that's what we've got here in our exercise. Then you need to convert it or write the equivalent of 2 sine x cos x. Okay, the reason this is a single x here in the integral we're going to evaluate later in this tutorial, and here double angle. So we have double angle, single angle. We need to convert this one from double to a single, and so therefore we need to use this identity there. Another identity that is very well handy and useful is the cos 2x. So we've done sine 2x. The next one will be is cos 2x. That's the next identity. Well, cos 2x is a popular one. There are 3 identities to cos 2x. The first one is being cos squared x minus sine squared x. Okay, that's the first one. And by using this identity here, like if you're making cos squared the subject, I can replace it here and it will give it to me in terms of sine. That is quite handy when we do this one here. So if I was to replace cos squared using this identity, it's going to be 1 minus sine squared and minus sine squared. So it's going to be 1 minus 2 sine squared x. All right. So that's the second one. The third one would be if I was to make sine squared the subject in this identity, that will allow us to write it in terms of cos squared. So it's going to be 2 cos squared x minus 1. Right, so these are the main ones for now and the most important ones. Okay, so let's go back to our integration here. How do I integrate this one? Obviously, we're going to use this one here. Okay, so let me just tick it. It'll be this one here. All right, so I need to make sine squared the subject in here. So let's write it down. So we're going to say cos 2x, that's the identity we have, is equal 1 minus 2 sine squared x. And by making sine squared the subject, it will be equal or identical to 1 minus cos 2x over 2, because there's 2 there. Now I can write it down as 1 over 2, split the fraction, minus cos 2x over 2. So that will allow us to replace the sine squared by this expression here, which is much easier to integrate the cos 2x than the sine squared. So let's replace it. I'm going to put it in bracket like this, and it's going to be half minus cos 2x over 2, close bracket, and then dx, of course. Let's not forget about the dx. So I'm going to perform kind of like expansions, or like expanding or opening the bracket, and therefore that will allow me to rewrite it as a difference of 2 integrations. So I is equal a half, and then you do this one with dx minus cos 2x over 2 dx. All right, so it's going to be a half integral dx minus, this is a half as well, a half of cos 2x, so I can take it outside, similar to this one, cos 2x dx. So the integral of dx is x, we know that, because the derivative of x is 1. There's a 1 there, right? So it's going to be a half x. Let's write it down as a half x. And then minus a half, what would be the integral of cos 2x? Well, the integral of cos, so where is it? Is a sine, isn't it? So basically, if I have cos x, so I need to do, let me just say that again. If I have the integral of cos kx, so I need to do 1 over k. Here I've got 2x, so we're going to need to do, again, multiply it by 1 over 2 sine 2x, right? Are we happy with that? Okay, so that's comes from this. And then plus c. So let's just simplify this into 1/4. So that will be the final answer, really. So therefore, the answer finally is half x minus quarter sine 2x plus c. And that's your answer. So this is how you integrate sine squared. Now the next task is, what is the integral of cos squared? So we are now integrating cos squared x dx. That's the task. I mean, in a similar way, use the identity, this one here. So basically you'll be using this identity. All right. Again, go ahead and do it. Pause the video, do it fully, and then come back, check your answer against mine. And then after that, we'll have a look at this integration, this exercise. All right. So for this integration, it has a cos squared. So we need to use this identity there. I'm going to tick it with the blue there. So let me just write it down. So we got cos 2x is equal to cos squared x minus 1. Again, we need to make cos squared the subject in this identity. That will give us quickly, without having to go through the working out, it will be cos 2x plus 1 divided by 2. And again, because I want to split the two fractions as we did before, now we can take this and substitute it into our integration. So let's continue here. So I'm going to also put it in bracket, of course. So we have cos 2x there over 2 plus a half, close bracket, that is dx. And you split the integrals into 2 because you've got two items here. This is a 2. All right, so again, and at the same time, I will take the half because this is a half and a half here. Of course, similar what we did in the previous one. So it's going to be half integral of cos 2x dx plus a half integral of dx. So I is equal, now cos 2x, if I go back to this one here, so we're integrating cos kx. Now our k is 2, okay, but the answer should be the same. So it should be 1 over k, 1 over k. So it's going to be 1 over 2 times 1 over k, the k is 2, and of course it's going to be sine 2x. Here is sine kx, here is k is equal to 2, so therefore sine 2x, you get the idea. Plus a half x, and plus that constant c, let's not forget about that one. Let's calculate here, is going to be a quarter, sine 2x plus a half x plus c, and that is the answer. And I hope that you have got the same answer as me. Right, so let's take a look at our main activity here. We need to evaluate between 0 and pi over 3 sine 2x cos x. So this one here will involve basically using this identity and then simplifying, and then we get to the squared. So probably we have to use one of these, all right? Either that one or that one. So we got sine 2x cos x, as I was saying at the beginning of this tutorial here. This is double angle, this is a single angle, so we need to convert it double to single. Okay, so we need to use this identity sine 2x. This identity will allow us to convert from 2x to one single x. So let's write it down here. So we've got sine 2x is equal to sine x cos x, and therefore if I did sine 2x times cos x, so let's do it here, sine 2x times it by cos x, therefore we'll have the cos x here will multiply by this cos x, and we will end up with cos squared x. So let's do that. 2 sine x cos squared x. So I'm going to leave it as it is. So let's rewrite the integration. So let's call it I is equal the integration or the integral of sine between 0 and pi over 3 of 2 sine x cos squared x dx. All right, so therefore we've got everything in single angle, all right, here and here, but the problem still have a power. Now I can go ahead and use one of these as we did earlier, this one here, sorry, this identity, to include cos 2x, but that will bring me back to double angle. I do not want to do that. So therefore, I need to use a different method. The method is going to be substitution method. So I'm going to call cos x, I'm going to call it u. So cos x will be called u now, and therefore I'm changing the variable from x to u. So therefore I need to change dx, so I need to differentiate this one here. So we're going to say du. Of course, I'm going to differentiate with respect of dx. So I'm going to write it down as minus, the derivative of cos is minus sine x dx. And then, of course, I need to make dx the subjects to substitute here. So dx is equal to du over minus sine x. Now you may say, oh, what about sine x? Okay, so just hang on for a while. You will see in a minute that will disappear. Okay, I'll show you why. So we got the integral is 0 pi over 3. Let's write it down. 2 times sine x, and then times, now I forgot to do that. Since this is cos x is equal to u, so therefore cos squared x is going to be u squared. That's what I'm trying to do here. Write it down properly. So the cos squared will turn to u squared, and dx will turn to du over minus sine x. And this is where the sine will disappear, and that's what happens usually with substitution. So you need to hang on for a while. Don't go and change this. So let's cancel them down. We'll be left with minus 2. I'm going to take the minus 2 outside the integral between 0 pi over 3, and we've been left with just u squared du. Now, how easy is that? I mean, we know how to integrate this one. It's going to be minus 2. Let's put it in bracket here. Well, let's put it in square bracket rather, because I'm going to substitute into the expression. Minus u3 over 3, and that is between 0 and pi over 3. Now, of course, I need to place back the u. So instead of u, we should have cos. So let's do that. It's going to be minus 2 of cos cubed x over 3 between 0 and pi over 3. And you can go ahead and grab your calculator and do this one here, and you should get 7 out of 12. Okay, I did this without a calculator because cos, we know that cos pi over 3, you can use the degrees as well. You can change this. This is 60 degrees, right? It's 180 divided by 3 is 60 degrees, which is a half. Now, you elevate it to power 3, so it's going to be, all this power 3 is going to be 1 over 8. And then we know that cos 0 pi, or 0 radian, I should say, is going to be 1. All right, same thing, you elevate power 3, you get 1. So basically we're doing just to show the working out without the calculator, minus 2 minus 2. I can take that 3 outside bracket, so it's going to be minus 1 over 8, minus 2 1/3, 1 over 8 minus 1. Okay, that gives me minus 2 over 3 times minus or negative 7 over 8. Which is negative times negative is positive 14. 2 times 7 is 14 divided by 24. And you cancel down, you give you this answer. All right, so that's the working out if you want to do it without a calculator. But anyway, you could do it with a calculator. So let me delete that. So that's the answer. All right. Okay, so we have come to the conclusion of this tutorial. Now, I hope that this video tutorial was very helpful to you. Thank you for watching and take care.